Hello, I'm Derek. I'm a software engineer here at Syntasso. And today I want to share with you a pattern that we see very common with our customers. That is, how do you share resources created by compound promises between like different resources of that particular compound? So to illustrate, let me share my screen. You can see, by the way, everything that I go through today is actually published in this blog. So when you have the time, go for it, give it a read. Hopefully it clarifies anything that is not clear from my presentation as well. And you can also have links for all the promises and everything that I show in here today. So the problem in particular is like, what do you do when you want to share resources between different like compound promises requests, right? So let's imagine if you go to our marketplace, you have a namespace promise. The namespace promise basically creates a namespace and sends that to the destination. So particular promise, let's call it the application promise. It may use the namespace promise as a compound promise, as a required promise. And within its pipeline, what it can do is actually output a namespace request. The namespace request is picked up by the namespace promise, and then the namespace is eventually created at the destination. So that's great. That works well. However, what if you have a second application B that should also be deployed to that same namespace? So you may say, well, the application B pipeline will actually output a T-Mobile namespace again, the same namespace, and that's going to be created, right? Not really. So if you're using Flux or Argo, this may actually fail at the destination because you'll say, oh, I have two sources of truth for this document now, and this is just not going to work. But let's say that you actually find a way and you're like, all right, if the namespace is already requested, I'm just not going to go and request a new one. I'm going to use the same one. That's going to be easy. So application request A, we actually go and create my namespace request, which will go and actually create my namespace. Application B sees that that's already requested, and then it just uses it. That works well until someone tries to delete it. Because the way that kratix works is that each one of the outputs of a pipeline produces a work. Whenever that request that created that work is deleted, it also deletes its works, which in turn will delete the namespace request that was produced by this particular request, which in turn removes the namespace on the destination, which would then inadvertently remove the application B that you deployed. So how do you solve this particular problem? We solve this problem with a thing that we call a claim. It's a design pattern. It's how you build your promise in a way that you have an intermediate promise that actually is responsible for creating the requests of the subpromises. In our example, it would work something like this. You have an application request, and let me actually go here. You have an application request, which will be one per application, and every request will actually create a claim. Right? A claim is a claim to a resource. We're using namespace here as a simple example, but this could be a database. This could be a Kafka topic. This could be whatever you are building as a service. You can use a similar pattern. And that claim request, the init pipeline, it will actually determine, do I need to create this resource or not? But instead of creating it declaratively as we are used to, it creates it imperatively. So it actually runs in the pipeline, okay, I need to create this request. And that is in turn will create the namespace on the other system. So in the first example, I have my application 1. The application 1 will go run its pipeline. This pipeline will produce a claim, and a claim will say app1 T-Mobile. That's the namespace that I want. The pipeline for the claim will run and detects, oh, I have no namespace for T-Mobile. Let me create one. So it will imperatively in the pipeline create that namespace request. The namespace request will then in turn trigger the namespace promise pipeline, which will then produce the necessary namespace to be deployed at the destination, as always. So when a second application comes in, it will also create its own claim. However, in the claim pipeline this time, this is going to be a no-op. The claim already exists. We can imperatively create it again if we want to, or I can just check this already exists. I'm not going to do anything. It's just going to be unchanged. So right now we have a namespace request, and this request is claimed, is owned by, is required by two different resources in your system. But there is only one work for this resource, which is the actual namespace that is being deployed. So when you delete the application 1, it will delete its claim. However, the claim pipeline, it will actually check, oh wait, this is still being claimed by one resource. So I'm not going to do anything about it. I'm just going to leave it there. That way, my namespace doesn't disappear. And then finally, when the second application is deleted, its claim is deleted, it kicks off the claim delete pipeline. The claim delete pipeline may look at the namespace like, oh, no one is claiming this anymore. I'm just going to go ahead and remove it. Or not, it's up to you. This is like, it's your code, your promise. You may want the namespace to be left alone. Though if this is a database, you may like, I actually don't want to delete the database. Other resources may come and claim it later. Just want to keep it around. It's up to you. But the matter is, that's only you decide when that resource disappears from your system. So I'm going to show you the promise that we have in this example. This promise is available in the marketplace as a namespace claim. Is an example, as a design pattern. Take a look at the pipeline. Take a look at the code. We're using the Python SDK to build this promise. It should be relatively straightforward. But again, if you have any questions about how to use this pattern, send us a note on Slack and I'll be happy to respond as well. So, but let's see this in practice. So I'm just going to open here my terminal, and here I already have the namespace and the namespace claim promise. So, and if I take a look at my worker cluster, you should see the namespaces that I have. So I'm just going to go ahead and create a few claims. So I'm actually going to copy what we have here in the blog post, and you can see that I'm creating a namespace claim, and the namespace that I want to create is the shared team namespace. So if I take a look at my pipeline, you should see it's first run the claim pipeline that I'm executing directly, and then it runs a namespace pipeline. So at this point, if I show you what we have in our state store, is one namespace that is owned by the shared namespace request. So if I take a look at my claims, namespace claims, you should see I have one claim. And if I take a look at my namespace promise request, which should be this one, you should see that I have one shared team namespace request in there, which is excellent. So let's go ahead and create another claim. This time I'm going to create a claim for team B, requesting the exact same namespace. So we can take a look at what the pipeline is actually executing here. You can see that the pipeline runs and it says, hey, that claim already exists, right? I don't actually need to go and create a new namespace request that already exists. This will just exit. If we actually take a look at the team A claim, you can see that it says, hey, I need to create one because it did not exist, which is great. So at this point, I should be able to see in my namespaces, I still have that one namespace, and in my claims, namespaces, you should see that I have those two claims. If again we look at our state store, I only have one. I only have a single work that represents that particular namespace that was requested. So that's so good. That proves that at least at the create part, everything works. So what happens when I delete a claim? So remember, the resource that created the namespace was actually the team A namespace. So if I delete that in the old world using the normal compound promise patterns, this will also disappear. But if I delete this here using the claims pattern, it will actually execute the delete pipeline, which I can show you in a second. Let's just finish. And the delete pipeline for this resource is actually gets deleted, so I'm not going to be able to show you. But what it does is actually checks, do I need to delete my claim? Do I need to delete my namespace? So if I take a look at my namespace, you see it's still there because it's still being claimed by one resource. So now I can finally go ahead and delete the final claim. So if I delete the team B claim, the pipeline will execute and then we'll check, oh, do I have any claims left in this namespace? The answer will be no, because I'm deleting this particular resource. Then it will go ahead and actually call imperatively the delete command on my namespace, which will make sure that my namespace goes away. And if I actually get my namespace here, you see that the namespace disappear. So you can have as many claims as you want. You're only going to create one resource, and you can delete as many claims as you want without actually impacting the resource. All the logic exists in the promise itself, in the claims promise itself. We are executing a configure pipeline that will ensure that we create the claim, and you're also executing a delete pipeline that ensures that we delete the claim. So that's all I had for today. The blog post goes in a little bit more detail, so I recommend you give it a read. And if you have any questions, please don't hesitate to contact us. Thank you.